Hello and welcome to another exam paper walkthrough. I'm continuing or finishing off the summer 2017 exam series. My school's year 10s have just done this as their mock exams, so I'm doing video walkthroughs. However, past papers are one of, if not the best forms of revision for any exam series, so this will be great revision regardless of when your exams are. Feel free to put some music on in the background. I've got some on my headphones just to break up the sound of listening to my voice for an hour or so. I hope you find this video useful. Subscribe if you like. If you've not already done so, one of the first things in the link to this video is a link that will take you to a PDF version of this paper. I would strongly recommend you either do it alongside or do it before you watch the video just to get the most out of it. And we'll make a start. Okay, question 1. That symbol stands for the universal set. The universal set of odd numbers less than 30. Set A is 3, 9, 15, 21, and 27. Set B is 5, 15, 25. Complete the Venn diagram to represent this information. Okay, so I'm just going to run through the odd numbers and put them in the correct area of the Venn diagram. So the number 1 is going to go there. We've then got 3 in set A. And set B, I'll label that as well. So 3, 5 is going to go in the intersection. 7 is in none. 9 is going to go in set A. 11 is outside. 13 is outside. 15, I've put 5 in the wrong place. 5 should have gone there, and 15 should have gone in the intersection. Then we've got 17 on the outside. 19 is going to go on the outside as well. We've then got 21, which is going to go in set A. 23 on the outside again. 25 just in set B. 27. And then finally 29. So put my comma in the wrong place. So we should have, if we think about it, we're going to have 15 odd numbers. So let's just check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There we go. So part B says, number is chosen from the universal set. What is the probability that the number is in the set A, U, B? So the union of A and B. So we've got 1, 2, 3, 4, 5, 6, 7 numbers in the union, so it's going to be 7 out of 15. Question 2, solve the simultaneous equations. So we've got quite a nice pair of simultaneous equations. We've got 3 x's in both equation 1 and equation 2. So we don't need to manipulate either of them, we just need to subtract one from the other. I'm going to subtract equation 1 from the, well, I'm going to do 1 take away equation 2. Reason for that is that will keep my y coefficient positive. So 3 take away 3 is, well, 3x take away 3x is 0. Y minus negative 4y is going to be 5y. And then minus 4 minus 6 is going to be minus 10. So divide both sides by 5, y would be equal to minus 2. And now I've got a value for y. I'm going to substitute y into one of my original equations, and I'm going to go for equation 2. So 3 lots of x minus 4 times minus 2 becomes plus 8 is equal to 6. So minus 8 from both sides, 3x would be equal to minus 2, and then divide both sides by 3, x would be equal to minus 2/3. And I'm going to finish with a very quick check with whichever equation I didn't use here. So I'm going to do a check with equation 1. So 3 lots of x is 3 times by that, so that would be minus 2. Plus y would be minus 2, and that would be equal to minus 4, which is what we were supposed to do. So we know that we're right there. So my value for x was minus 2/3, and my value for y was minus 2. Question 3. The table shows some information about the dress sizes of 25 women. We've got dress sizes ranging from 8 to 14, and we've got numbers of women. Find the median dress size. So if we're talking about 25 women, the median is found by when they're in Median is found by arranging them in size order and then finding the middle value. We can do that from a group of 25 by adding 1 to it and then dividing by 2. So 26 divided by 2 would be 13. So we're looking for the 13th value. So we've got, I'm just going to kind of keep some of the cumulative frequencies going. So we've got 2 that are 8 or less. We've got 2 plus 9, we've got 11 that are size 10 or less, which means that we've got 19 that are size 12 or less. So the 12th to the 19th value are both, or are all 12s, so the median is going to be 12. Okay, 3 of the 25 women have a shoe size of 7. Zoe says that if you choose at random one of the 25 women, then the probability that she has either a shoe size of 7 or a dress size of 14 is 9 over 25, because 3 over 25 plus 6 over 25 is equal to 9 over 25. Is Zoe correct? You must give a reason for your answer. So this would only be true if they're mutually exclusive. Is Zoe correct? No. They are not mutually exclusive, and then what I mean by that is a woman can, I was going to say can be, and I've written can be dress size 14 and shoe size 7. Question 4. Daniel bakes 420 cakes. He bakes only vanilla, banana, lemon and chocolate cakes. 2/7 of the cakes are vanilla cakes, 35% of them are banana cakes. The ratio of the number of lemon cakes to the number of chocolate cakes is 4 to 5. Work out the number of lemon cakes Daniel bakes. So I'm going to set this up using a bit of a ratio table. So I've got vanilla, banana, lemon and chocolate, and then I'm going to put the information in at various points. So vanilla is 2/7. We've got 35% are banana, and then the ratio of lemon to chocolate is 4 to 5. Right, so if we know that there are 420 cakes, we can work out the vanilla and the banana number, which can tell us, and we can do it all from there really. So if I'm splitting 420, then the number of vanilla cakes I've got is going to be 420 times by 2/7. So 420 times by 2/7. So we've got 120 vanilla cakes, 35%, so 35 times by 420 is 420 times by 0.35. So we know that there are 147 banana cakes. So that means that we've got a total of 147 plus 120. So we've got a total of 267 cakes so far. So that means that the total of lemon and chocolate is going to be 420 minus the answer that I just worked out. So we've got 153 lemon and chocolate cakes, and then if we're told that we've got 4 to 5, the number of lemon cakes is going to be this one here. So I'm going to do that as 153 times by, and I'm going to say that that's 4/9. So if I times that by 4/9, that's going to give me 68. So in effect, I've got 68 there. So 68 lemon cakes. Question 5. In the diagram, AB, BC and CD are 3 sides of a regular polygon P. Show that polygon P is a hexagon. You must show your working. I'm going to just look at the exterior angles, and I'm going to say that the 2 exterior angles need to add up to 90 degrees. The exterior angle of a 12-sided shape is going to be equal to 360 divided by 12, so it's going to be equal to 30. So the exterior angle of P is going to be equal to 90 minus 30, so it's going to be equal to 60 degrees. So the number of sides of P is going to be equal to 360 divided by 60, which is going to be equal to 6. So P is a hexagon. Question 6. The density of apple juice is 1.05 grams per centimetre. The density of fruit syrup is 1.4 grams per centimetre. The density of carbonated water is 0.99 grams per centimetre. So 25 centimetres cubed of apple juice mixed with 15 centimetres cubed of fruit syrup and 280 centimetres cubed of carbonated water to make a drink with a volume of 320. Work out the density of the drink. Interestingly, this 320 is a bit irrelevant because 25 plus 15 plus 280 is 320, so we could have worked it out from there, but not to worry. So I'm going to look at the three different, so we've got apple juice, we've got fruit syrup, and we've got water, and it mixes to make a drink. So in effect, I'm going to look at density, mass, and volume, and then I'm going to put the information in. So we've got density of 1.05, 1.4, 0.99, and then we've got the volumes, 25, 15, and 280. And we've got this volume here of 320. So we need to work out the mass of this before we can work out the density. So we need to work out the mass of all of these. The masses of these are going to be found by multiplying them, because if density is equal to mass divided by volume, then mass is going to be equal to density times by volume. So I'm going to work out these three masses and add them together to find out the total mass of the liquid. So 25 times by 1.05 is going to give me 105 over 4. 1.4 times by 25 is going to be 35. And then for water, 0.99 times by 280 is going to give me 1,386 over 5. So the total mass of the liquid is going to be that plus 35 plus 105 over 4. So we've got a total mass of 6,769 divided by 20. So the density of this liquid is going to be equal to the mass divided by the volume. So I'm just going to type it in like that rather than write it because I've got the two values there and there. So the mass that I've got divided by 320. So as a as a fraction, that's going to be 6,769 divided by 6,400. So as a decimal, that's going to be equal to 1. So I pressed the wrong button there. SD, that gives me the value of 1.05765. So to 2 decimal places, that's going to be. So I've just been back and checked some of my values, and I've actually got the wrong value here. I must have done the wrong sum at the time. That should have been 21, which changes this value slightly. So I'm just going to change some of these because I was slightly out with my answer. So if I do 21 plus 1386 over 5, over 5 plus 105 over 4. My total mass should have been 6489 over 20, which means that my my density would have been that divided by 320, which gave me that value, slightly different, 6489 over 6400, and then that as a decimal, that looks right, 1.013909625. So to 2 decimal places, then that's going to be 1.01. There we go. Okay, question 7. ABC is a right angle triangle. So straight away, calculate the length of AB. So I'm going to call that X for now. And then we've got a right angle triangle where we're dealing with 2 sides and 1 angle. So we're looking at trigonometry. So I'm going to label the 2 sides that I'm dealing with. AB is, or X is the opposite, and then the 15 is the hypotenuse. So I'm using my trig ratio with an O and a H in, which is the sine ratio. So sine is equal to S over H. And I'm trying to work out O, so if I rearrange that, O is going to be equal to S times by H. So substitute in then, X is going to be equal to the sine of 23 multiplied by 15. So sine of 23 multiplied by 15. So that gives me 5.86096 ... So to 3 significant figures, that's going to be, the number behind that 6 there is 0, so it's going to be 5.86. Okay, question 8. A square with sides of length x centimeters is inside a circle. Each vertex of the circle is on the circumference of the circle. The area of the circle is 49 centimeters squared. Work out the value of x. Give me your answer correct to 3 significant figures. Okay, so let me draw that better. Okay, so that's very rough. Well, that's a diagram of what we've got. So in effect, we're told that this length here is x, and we're told that the area of the circle, or area which it would be pi r squared, is equal to 49. So what I'm going to do is I'm going to say, I'm going to call it r for now. So and I'm actually going to label it R and R there for now. So I'm going to say that the area of the circle, which is 49, is equal to pi times by R squared. And that actually works quite nicely for me. So R squared is going to be equal to pi over 49. And I'm going to stop there for now. So if I'm trying to work out the length of x, x squared is going to be equal to r squared plus r squared, or 2r squared. So x squared is going to be equal to 2r squared. So square root both sides, x would be equal to root 2 times by r. So I can substitute in at this point, really. Realistically, I left it as r squared there because I thought I'd be using r squared, but I've kind of just gone past it. So pi over 49. So that's going to be the square root of 2 times by square root of, let's try that in better. Actually, what I'm going to do is I'm going to r squared, so I'm going to say r squared, x squared is going to be equal to 2 times pi over 49. So x is going to be equal to the square root of 2 pi over 49. That just tidies it up a little bit better. So the square root of, I want a fraction, my numerator 2 times by shift pi, and then my denominator 49. So I've just looked and I've actually rearranged wrong here. It should have been 49 over pi, so I've got that the wrong way around. So let's just switch that around, and then that hit here and here. So that should have been 2 times by 49 over pi. So here, 2 times by 49 over pi. So let's change that over here. So we've got pi there, and then 49 there. There we go, that looks better. So we're saying that x is going to be 5.585191 ... So we were asked to do it to 3 significant figures again. So 3 significant figures, we'd round the 8 up to a 9, so 5.59. Okay, question 9. The box plot shows information about the distribution of the amount of money spent by some male students on their holidays. Work out the interquartile range. So this is the interquartile range here. So if we look, we're going from slap bang in the middle there and slap bang in the middle there. Then if we look at the scale on this, so we're going up in 20s. So we're going 20. So that's 150, and then we're going up to 330. So my interquartile range is going to be 330 minus 150, which is going to be 180. Table shows information about the distribution of the amount of money spent by some females on their holiday. On the grid, draw the box plot for this information. So I'm going to try and make this look very similar to the boys. So the smallest value spent by the girls is 60, which would be, let's go for that there. I'm just going to mark these on. The lower quartile was 180, so that would be there. The median would be 300. The upper quartile 350. And then the largest amount was 650. So I'm just going to make that into a similar box and whisker plot. Okay, so there's my completed box plot. I should label it that this is female students. Okay. And then, have we got a final part? Yeah. So Chris says the box plot shows that female students spend more money than male students. Is correct, Chris, correct? I'm going to clarify the statement, but I'm going to agree with it. Yes, what I'm going to say is yes, on average, the median girls spend more than boys. So yes, on average, and I'm going to state the average, the median, girls spend, or actually, females spend more than males. And then I will compare the figures. So the females was 300 versus, and the boys was 250. Actually, rather than versus, I'm going to say 300 is greater than 250. Question 10. Niobe invests 6,000 for 5 years. The investment gets compound interest of X% per annum. At the end of the 5 years, the investment is worth £8,029.35. work out the value of x. Okay, so I'm going to use a different letter to x because I'm not going to be working in percent, I'm going to be working as the multiplier. So I'm going to call that y. So I'm going to say that 6,000 times by y to the power of 5 is going to be equal to £8,029.35. So y to the power of 5 is going to be equal to 8,029.35 divided by 600. 6,000, sorry. So y is going to be equal to the fifth root of 1,029.35 divided by 600. And then that value for y should be a number just above 1, sorry, 1 point something, I think 1 point something 5 or 6, and then we're going to have to convert that into a percentage. So I want to do the fifth root of a fraction 8,029.35 divided by 6,000, and what we're looking at, there we go. So 1.059999 ... So that's going to be 6.99%. I'm going to go 6.0%. Question 11. Jeff is choosing a shrub and a rose tree for his garden. At the garden centre there are 17 different types of shrubs and some rose trees. Jeff says there are 215 different ways to choose one shrub and one rose tree. Could Jeff be correct? You must show how you got your answer. Okay, so I'm going to kind of try and answer. Can the number of shrubs, so let's say S, times by the number of rose trees, which I'm going to call R, be equal to 215? That's kind of the question that I'm asking myself. So we're told that there are 17 different, so can 17 times by R be equal to 215? So, and give us R as an integer. So, the number of roses that it should be is equal to 215 divided by 17, which I don't think we can do. No. So can't. So which is equal to 12.647. So R must be an integer. So Jeff is wrong. Okay, question 12. The points A, B, C, D lie in order on a straight line. The ratio of A to B to B to D is 1 to 5, and the ratio of A to C to D is 7 to 11. Work out A to B to B to C to C to D. Okay, so let's just kind of set up a very messy ratio kind of table. So A to B to B to D, so in effect we're breaking our ratio kind of here, is 1 to 5, and then the ratio of A to C, so kind of let's just that line to that line, and then the ratio of A to C to D is 7 to 11. Okay, so we've got 6 parts to this ratio, and we've got 18 parts to this ratio. So they can't be, if we're trying to combine them, A to B, B to C, C to D. So we want the kind of the end goal to A to B. Yeah, we want those 3 parts. So we need to have them both being ratios with 18 parts. So I'm going to times this one by 3. So if I convert this, first ratio to 18, it would be 3 to 15. Right, so that means that A to B is going to be 3, and C to D is going to be 11. And then in the middle, then we must have, well, we've accounted for 14, so we must have a 4 there. So that must be 3 to 4 to 11. Okay, question 13. Write down the 3 inequalities that define the shaded region. So I'm going to start by labeling these 3 lines. So the first one is y is equal to 2. This one here is y is equal to x. And then this one here has an intercept of 1 and a gradient of a half. So it's going to be y is equal to a half x plus 1. And then if I pick a point with it in and then kind of look, so y has to be greater than 2. Greater than or equal to, they're not dashed lines, so greater than or equal to 2. My next one is y has to be greater than x, or y has to be greater than or equal to x. And then the final one is below the line, so y has to be less than or equal to a half x plus 1. There we go. Okay, question 14, simplify. So here we've got a difference of 2 squares, so that would be x plus 4 times by x minus 4 if I factorised it. And then if I try and factorise the denominator as well, we've got a 2x, so my brackets must start with a 2x and an x to make a 2x squared. And then I'm looking for 2 numbers that multiply together to make 12, and then 2 lots of one of the number plus the other number add together to make 5. And it's going to be 4 and 3 in some combination. So if I do minus 8 plus 3, that would work. So I need minus 4 there and plus 3 there. So those brackets would cancel, leaving me with just x plus 4 over 2x plus 3. Okay, and part B, make V the subject of the formula. Okay, so I'm going to get rid of the V as the denominator by multiplying through by V, so WV, and I'm also going to expand this bracket, so 15t minus 30V. I'm then going to take all my V's over to this side and factorise at the same time, so V times by W plus 30 is going to be equal to 15t. And then divide by that denominator. So V is going to be equal to 15t divided by W plus 30. There we go. Okay, question 15. The area of the triangle ABC is 6 root 2 meters squared. Calculate the value of x. Give your answer correct to 3 significant figures. So we're going to use the advanced trig formula for the area. So we're going to say that our area is equal to a half AB sine C. So the area we were told was 6 root 2, and that's got to be equal to a half of x plus 3 times by 2x minus 1, and that's going to be equal to, times by sine 45. Sine 45 is root 2 over 2, I believe, sine 45, not best, yeah, root 2 over 2. Okay, so if we rearrange this slightly, that's going to be over 4, so I'm going to times by 4 and divide by root 2 on both sides, which will cancel the root 2, and it's just going to leave us with 24 here, and that's going to be equal to, I'm also going to multiply this bracket at this point, So that would give me 2x squared minus 1 plus 6, so plus 5x minus 3. Okay, and so that's going to give me, if I take everything over to the one side, 0 is going to be equal to 2x squared plus 5x minus 27. Hint in here is that it's not going to factorize, so I've got the choice of either completing the square or substituting into the formula. I'm going to complete the square just because that's my preferred method. So I'm going to say that 0 is going to be equal to 2 open bracket x plus 5 over 2. From that, I'm going to have to minus 25 over 4 times by 2. 25 over 4 times by 2 becomes 25 over 25. Sorry, so I'm going to have to subtract from that 5 over 2 squared, which will be 25 over 4 times by 2. So I'm going to have to subtract 25 over 2, but I've still got to subtract 27. So if I add 27 to that, so so I'm going to take that over to the other side and say that 79 over 2 is going to be equal to 2 lots of x plus 5 over 2 squared. So divide by 2 on both sides, so 79 over 4 and then square root. So it's going to be minus 5 over 2 plus or minus the square root of 79 over 4. That's going to be minus 5 plus or minus root 79 over 2. So I'm going to have two values then, and if we're thinking about this is the value of x, we can't have can we have a negative value of x? We can't. No, we can't. We technically could have a negative x, but we can't have a negative length, and if x was negative, that would create a negative length there, so we can ignore the negative version. So I'm just going to go minus 5 plus root 72, root 79, sorry, and then I want to divide that answer by 2. So that's going to give me 1.944. And again, I've just spotted a mistake that I made here. When I took 2 out as a factor here, I didn't take 2 out as a factor of this. So that should have been over 4. So that's quite a big thing, quite a silly mistake. So let's look at that bits again and correct them as we go. So 5 over 4 all squared would have been 24 over 16, and then we times that by 2. So that should have been 25 over 8 minus 27. I didn't mean minus 27. Sorry, let's do that again. 5 over 4 all squared. That would have given us 25 over 16, and then times that by 2. Would have been 25 over 8 plus 27 would have been 241 over 8. So this would have been, let me just change a few things here and here. That should have been over 4. And this was 241 over 8. So 241 over 8. Not over 8, because we're dividing through by 2, so that would be 16. And then that would have been over 4. So let's try that. So minus 5 plus the square root of 241. And then I want to divide that by 2. And then that gives me 5. There we go. And I should have divided by 4, not by 2. So divide by another 2. So I'm going to say that that's minus. I'll write it down again. No, that's exactly what I've just written down there. There we go. So as a decimal, that's going to be is equal to x is equal to x. So x as a decimal is going to be 2.631. 3 significant figures. I've gone too far. That's bad form on me. So I'll do that there with more decimal places. 2.631043 ... So 3 significant figures, 2.63. There we go. Apologies about that mistake. Okay, question 16. So we're using the iterative formula here. So it says the next value of x, or x of n plus 1, is equal to minus 2 minus 4 over I'm not really happy about where that squared is hitting. X of n all squared. With x0 being equal to minus 1.25. Find the values of x1, x2, and x3. So we're just going to use our calculator for this. So we start with putting minus 2.5 in as our first value for x, or x0. So I want to do minus 2 minus 4 lots of the answer squared. And then every time I press equals, it will just give me my next value. So the first one is minus 66 over 25. And I should really do the decimal versions of this. And I've messed that up. Let's do that again. I should have pressed SD, not equals. So we'll do that again. So minus 2.5 is my answer. And then I want to do minus 2 minus as a fraction 4 over the previous answer squared. So the first value is minus 2.64. The next value is minus 2.5739. And then the next value is minus 2.6038. Okay, part B then says explain the relationship between the values of x1, x2, x3 and the equation x cubed plus 2x squared plus 4 is equal to 0. So if we kind of look at this, if we times, so x is equal to minus 2 minus 4 over x squared. If we times through by x squared, that would give us x cubed is equal to minus 2x squared minus 4. And then if we rearrange that, that would give us x cubed is plus 2x squared plus 4 is equal to 0. So explain the relationship between them. They are iterations are an estimation of the solution to the equation. The iterations are estimates of the solution of a solution to x cubed plus 2x squared plus 4 is equal to 0. Okay, question 17. A train travels along a track of 110 in 110 minutes, correct to the nearest 5 minutes. Jake finds out that the track is 270 kilometers long. He assumes that the track has been measured to the nearest 10 kilometers. Could the average speed of the train have been greater than 160 kilometers per hour? Well, speed is equal to distance divided by time. Could the average speed have been greater than? So we want to find the maximum. So we want we want the upper bound of S. To do that, we need to take the upper bound of the distance and we need to divide it by the lower bound of the time. So the upper bound of the distance is going to be equal to, if it's measured to the nearest 10 kilometers, then the upper bound, so the upper bound of the distance is going to be equal to 275 kilometers, and the lower bound of the time is to the nearest 5 minutes. So that would be 105. No, that wouldn't be 105. That would be 107.5 minutes. Right, so I'm going to use the time function on my calculator to convert this into hours. Actually, I'll show that. So 0 hours and 107.5 minutes is equal to 43 over 24 hours. So the upper bound for the speed, or speed u, is going to be equal to 275 divided by the answer that I just read out, which is going to give me 153. 153.488 kilometers per hour. So know the maximum speed. Is 153.488 kilometers per hour. Jake's assumption was wrong. The track was measured to the nearest 5 kilometers. Explain how this would affect your answer. It would still be a no. So, would this affect my answer? No, it wouldn't. The maximum speed would still be below. Would this affect your decision to part A? No, as maximum speed would decrease. No, as max speed would decrease as distance would decrease. Okay, question 18. A, B, and C are points on a circle of radius 5 centimeters at center O. D to A and D to C are tangents to the circle. O to D is 9 centimeters. Work out the arc length of ABC. So we want this length here. Okay, to do that we need to work out the angle AOC first of all. And we're going to do that by, first of all, we're going to have trigonometry here. Again, And if I want to work at that angle there to start with, we've got the hypotenuse and the adjacent this time. So we're looking at the cos ratio. So cos is equal to adjacent over hypotenuse. So the angle is going to be equal to cos to the minus 1 of 5/9. Okay, so if I want the arc length is going to be equal to 360 minus 2 lots of the angle divided by 360 times by the radius of the circle is 2 pi r. Okay, actually, and I'm going to just replace the r with 5. So let's change that for times by 5. Okay, right. So I'm going to go slightly going to. So right, shift cos of, and then I'll type it in as 5/9. So that's going to give me that value. So if we do the whole thing, 360 minus 2 times by the answer that we just worked out, divided by 360, and then we want to times that by 2 times pi times by 5. So we make it 21.59827 ... So to 3 significant figures, that's going to be 21.6. Okay, question 19. 2x squared plus 3x minus 2 is greater than 0. So we need to solve that. Right, so I'm going to try and factorize it first of all. And I'm going to say it's equal to 0 just for now. So that's going to be 2x and an x. So two numbers that multiply together to make minus 2, and 2 lots of one number plus the other number make 3x. So it's going to be 2 and a 1 with the negative there, because that will give me 4 minus 1. Right, so that means that x is going to either be equal to a half, or x is going to be equal to minus 2. Now I'm going to look at the inequality. We were actually after, so we've got positive quadratic, and we're actually after the bit where the graph is greater than 0. So I'm going to say that that is when x is less than minus 2, or where x is greater than a half. Okay, question 20. The equation of a circle is y is equal to a to the power x. A is the point where the curve crosses the y-axis. So state the coordinate of a. So in effect, for it to cross the y-axis, x must be equal to 0. And if we think about y being equal to a to the power 0, a to the power 0 is 1. So y would be 1. So it would cross at 0, 1. Okay, the second part, the equation of the circle C is x squared plus y squared is equal to 16. Circle C is translated by a vector of 3, 0. So it's been moved across by 3. Come back to that in a second. Draw a sketch of circle B, labeling the center of the circle and at any points of intersection with the x-axis. Okay, so if we are the center of this circle is 0, 0, and it has a radius of 4. So if we are moving it by a scale of 3 across, it's just going to become 3, 0 is going to be our centre. And then if we think about points of intersection with the y-axis, if we've got a radius of 3, and actually intersection on the x-axis is fairly straightforward because we've got a radius of 4, so it's going to cross at -1, 0 and 7, 0. So let's try and draw it actually. Okay, so if I insert circles to start with, and then I'm going to also insert the x-axis. And then if we say that that's going to be my x-axis, then we can mark on the center at 3. And then we've got a value here of -1 and a value here of 7. And then I'll put my y-axis in. So if I come at my y-axis, and I don't have to put the intersections on the y-axis, I thought for a moment we might have to, and we could work them out using a bit of Pythagoras, but it doesn't ask for them. So there we go. Okay, and that brings us to the end of the paper. Right, before I sign off, I will just bring up the skills map for that paper. This is a link, all the questions that we've just done, this is the link to the skills that they relate to. So for example, if you struggle the most on question 16, that's growth and decay and compound interest. So that might be where you want to focus some of your targeted revision before your actual exam. Thank you very much for your time in listening. I hope you find it useful. Feel free to add any questions, comments, or feedback into the chat for this video, and I'll get back to you fairly promptly. I'm fairly quick with that. And please do subscribe if you like.